Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about the idea of dilation, and that is very simple really. It is all about stretching or shrinking the graph by multiplying the basic function. We have original basic function, which is fx, so we can change and get a new function by multiplying this with some constant. So here the constant is greater than 1, and let's say you are interested to see how the new function looks like. There is an easy way to sketch the graph by following the simple rules given on this table here. So let's talk about the rules. First of all is if you multiply the function fx with a constant c. So fx is y, and whenever you talk about fx, you talk about vertical axis, and therefore you can expect that the graph in this case will have a vertical sort of change, and in this case it will be vertically stretched with factor c. Okay, now if you multiply fx with 1 over c, so here is going to be another change with respect to vertical axis here. So this is the vertical axis, and therefore you will see that the graph will be vertically compressed with factor c. Okay, next, let's say you make a change with respect to x by multiplying x with a constant 1 over c, and in this case the graph will be horizontally stretched. Okay, so you make a change with respect to x. Whenever you talk about x, you talk about horizontal axis, and therefore it makes perfect sense that the graph or the new graph here will be horizontally stretched. Okay, so next is if you multiply x with a constant c, then the graph will be horizontally compressed. Now it might be a bit difficult for you to try and remember all these concepts, but if you go on and practice with simple graphs by plotting points and so on, I hope you will be able to see what exactly what it means by all these terms: vertically stretched, vertically compressed, horizontally stretched, and horizontally compressed. Right, let's look at some examples just to illustrate the idea of this stretching and shrinking the graph. So here, let's say that this is the original basic function that you have, which is x squared minus 2, and this is given by this red line here, which I'm going to highlight. Okay, so this is the basic function, and you can see that this function here is then modified, and you get the new function. So this is the new function where there is a new element here, where you can see that for this one there is a multiplication of fx with a constant, so 1 over 2 times fx. So this is fx, yeah. So how do we visualize the look of this new graph? So like I said earlier, instead of trying to get all the points by substituting the values of x, what you can do is you can use the rule given here. So this is this case, 1 over 2 times fx, and you know that the graph will be vertically compressed. So what it means by vertically compressed is that at point 0 it will be maintained as it is. So here at this point they act as an anchor, so it's not going anywhere, it stays at the same point here. But when you say it is vertically compressed, you can imagine pushing this point upwards, pushing this point upwards, pushing the points here upwards. So you compress on both sides. So if you compress from both, if you imagine applying pressure to this point, so the point here will be moved upwards. If you're applying pressure downwards here, so the point is going to be moving somewhere here, so the point is moving downwards. So that's the idea of compressing this function. Okay, so the new graph here is going to be slightly wider compared to the original graph. Okay, now let's look at the next example here. So this is the basic function, which is sine x. So it is given by this one. So this is the basic function. Okay, sine of x. Then you can see that the new function here. Okay, so there is a new function. The new function here, so this is the new function, is created by multiplying 6 with the original function, which is fx. And this is the case given by this one, and we know that for this one the graph will be vertically stretched. So what it means is that for a point that is on this axis, it will remain as it is because these points are anchors. They are not going to move anywhere. They're just going to stay right there. But other points, for example, if you talk about vertically stretched, that you can imagine pulling this point upwards. So you stretched upwards, so it gets this point. Okay, by factor c. So by factor 6 in this case. Okay, so for example, this one also will be pulled upwards. This will be pulled upwards. So you will get this new curve over here. So 0 is not going to go anywhere. It acts as an anchor. And for this one, it will be stretched in this direction. Okay, so in this direction. So you have the similar shape of graph except that it is being stretched. Okay, being stretched. So you're moving this in this direction. So you will get this new graph here. Okay, so basically that is the idea of vertically compressed and vertically stretched. Okay, next, another example here is this. Based on this example, can you guess which graph is being horizontally compressed and horizontally stretched? Now, the original graph is given by this one here. So this is the original graph. This is the original graph. So you can imagine, if we talk about horizontally compressed, we talk about horizontally compressed here. So compress means you are pushing it inwards from both directions. In this direction, it's going inwards. In this direction, it's going inward. So if you're pushing it or compressing it horizontally, then you will get the new graph as this one. So this is the new graph, and so it is being horizontally compressed. Okay, so this is described by this green function here. Now, if you talk about horizontally stretched, so horizontally stretched, you can imagine that this is the graph and it is stretched in both directions, which is it is stretched outwards in this direction. It is also stretched in this direction. So all the points here will be stretched. This point will also be stretched. And so you will get the new graph that looks like this. So the graph here is horizontally stretched, and it is described by this function. Y is equal to, let me just erase that for you to be able to see clearly. So it is described by this function here, where you introduce 1/4 next to x. So this is horizontally stretched. Alright, I think that's all for now. Thank you very much for watching.